welcome to this session on thanatology. So today we are into the beautiful realm of forensic medicine, and forensic medicine is a subject which have fascinated many medical students. And in this channel also, I am starting forensic medicine. You must have observed from the last 3 days, I have been posting videos of pathology, microbiology, pharmacology, and FMT. The logic behind is that we'll have covering all the subjects of MBBS, and obviously I won't do it alone, but in future I will that in this channel many new faculties will be coming and teaching you some different subjects. But till then, bear with me, and I hope you are enjoying the lectures which I am taking. Do read along with that lectures, but I believe that the lecture is more than sufficient. If you make the notes and read the lecture and listen to the lecture very carefully, then you can do everything. And here we follow the chalk and talk method, not by any PPT or so. And that's an advantage, I guess. So without any delay, let's start this beautiful chapter, thanatology. So thanatology refers to that study of death in all its aspects. Okay, thanatology, this term basically means study of death in all its aspects. So we are studying about death, how death has occurred, what are the changes which we'll encounter, what is somatic death, what is molecular death, what is the supravital period, and the supravital period is the time lag between the somatic death and the molecular death. Somatic death is the death in which there is a phenomenon called Jaskow's phenomenon, and there will be positive pupillary reflex present in the uh, person. But whenever there is molecular death, there is a death of individual cells. So when we talk about death, it may be somatic or molecular. We generally think that death means stoppage of all functions, whereas we refer to the molecular death. Okay, molecular death, cellular death it is called. So cellular death is, or molecular death is the stoppage of all the functions of the body. Stoppage of all the individual cells will shut down here. Okay, and the supravital period is the time lag in which the organ transplantation is very well done. Okay, and in forensic medicine, whenever a victim comes, you have to examine what are the changes, what are the post-mortem changes which has occurred, and this post-mortem changes will give you an idea of the time since death. Will give you an idea of time since death, and will also give you hints on what has caused the death of the concerned person which have come to you. As a forensic medicine, you know, knowledgeable person, or I can say doctor. Okay, as a medical graduate, you have to know the different aspects of thanatology. In which the most important aspects are the post-mortem changes. These changes may be a bit confusing, maybe a bit lengthy to understand, but these are very interesting things. Okay, we can't say that this is not such a boring thing like studying about bacteria, fungi, viruses. Not like that. It is a practical, interesting, and you must have seen the TV channel CID TV show, and you might be fascinated with that Salunki. Okay, understood. So that feeling, let's develop within itself, with ourselves, so that we'll be more happy, and get a craze for forensic medicine, to read forensic medicine and to score good marks in forensic medicine, right? So today we start with forensic medicine, and I have chosen the topic thanatology for that. So let's talk about study of death. Okay, let's talk about death, and the basic topic we will be discussing are the post-mortem changes. What are the changes which will be occurring just immediately after death, or just following death, or which are the late changes? So some are early changes, some are immediate changes first. Okay, immediately after death. Some are early changes and some are late changes. So we categorize this post-mortem changes, okay, into early, or first, right, immediate changes. Some are early changes and some are late changes. So these are the basic categorization of the changes which are occurring after the death of the person. Okay. So let's start. Let's start with immediate changes. So immediate changes are the changes which are occurring in the somatic death period. Okay. So here three things are important. Okay. Heart, lungs, and the eyes. Okay. Just remember like this. So immediate changes is categorized, or immediate changes is thought to be composed of three things. There is a cessation of circulation, there is a cessation of respiration, and there is a loss of muscle reflexes, or the pupillary reflex also. Okay. So three things, basic three things you have to write here. Okay. Cessation of circulation, cessation of respiration, and third is the loss of muscle tone and pupillary reflex. So this is about the immediate changes. Let's talk about the early changes now. Early changes. So early changes are many things. So starting with the skin changes. What are the skin changes following the death of the person? Okay. What are the skin changes? And the skin will show basically the earliest change seen in the dead body. Remember, it is the skin change only. So there is a loss of turgor. Okay. There is a loss of turgor of the skin. There is a loss of temperature of the skin. There is a loss of elasticity of the skin as well. Okay. So early changes. First one is the skin changes. Skin changes. So one is the loss of turgor. Turgor means the the tone of the skin, or the basic form of the skin. Okay, there's a loss. Okay, understood? And there is a loss of temperature of the skin, and there is a loss of elasticity of the skin. Then let's talk, and remember, skin changes are the earliest changes which I have to see. Earliest, earliest changes which are seen in the dead body. Then Uh, after skin changes, we talk about eye changes. Okay, eye. What are the changes in the eye? So there is a sinking of the eyeball. Okay, there is a sinking of the eyeball due to the decreased intraocular pressure. Okay, the intraocular pressure, the pressure inside the eye decreases. Okay, since the aqueous humor, you know about that IOP. IOP means the aqueous humor, the pressure exerted by intraocular pressure is the pressure exerted by aqueous humor. Okay, aqueous humor. So this aqueous humor production stops in death. Stops in death. So there is a decrease in intraocular pressure, and if there is a decrease in intraocular pressure, the eyeball will sink in. Okay, so there is a sinking in of eyeball occurs. So there is a sinking in of eyeball occurs. Okay, the intraocular pressure reduces to even 50% after the 30 minutes after the death. Okay, and after 2 to 4 hours, after 2 to 4 hours of death, IOP nearly becomes zero. IOP nearly becomes zero. Okay, and the special point about in eye is the tachenoid deformity. Tachenoid de la sclerotic. The full form is tachenoid de la sclerotic, but we tell it tachenoid in common language. Okay, tachenoid de la sclerotic. Tachenoid de la sclerotic. So what is this problem? Okay, make stars here because it is important. The signs are important basically. So what is this tachenoidea sclerotic? It's a reddish brown discoloration across the sclera. Is the reddish brown discoloration across the sclera? Okay, let's assume this is your eye. Let's assume this is your eye, and here we draw the eyeball. Okay, so there is a reddish brown strip present over here. Look at this, a reddish brown strip like this, and this is called as the tachenoid sclerotic. Okay, and it is independent of the etiology of death. It will not tell about the etiology of death, and this is due to actually this is due to the drying of the eyeball. Okay, basically the eyeball has dried, due to which the blood is stasis occurs. The stasis of blood occurs, and this deformity appears. Okay, and another thing, the first thing was the decrease in intraocular pressure. One, eye changes. I'm talking about one, and second thing was the tachenoid deformity. Third thing is the add pages. So we'll require more pages today. Okay, the third thing. The third thing is the loss of potassium in vitreous humor. There is a loss of potassium in the vitreous humor. Sorry, there is an increase in potassium concentration. I'm writing increase in potassium concentration in the vitreous humor, because this increase in potassium or hyperkalemia. Since what happens is that the cells will die, okay, and there is a loss of K plus, and this K plus comes to the vitreous humor and increase in so there is a hyperkalemia in the vitreous humor, and this is an important biochemical parameter for estimating the time since death. Important for estimation of TST means time since death. Understand? Fourth change is a very important sign known as Kevorkian sign. Put stars here again. Kevorkian sign. So, what is Kevorkian sign? Kevorkian sign is the stasis of blood, in the retinal blood vessels. Okay, the stagnated column of blood in the dilated retinal blood vessel is called as Kevorkian sign. You will write stagnant columns of blood in the dilated. I will make you understand first, right? Retinal blood vessels. So what happens is that, just assume that this is the retina. Okay, and here, okay, this is a retinal blood vessel. Let's assume that this is the retinal blood vessel. Okay, this is the retinal blood vessel. So what happens is that after death, what happens? The retinal blood vessels will dilate. The retinal blood vessels will dilate, and this dilation, just make this color coding, maintain this color coding. Dilated blood vessels, dilated retinal vessels. Due to this dilation, there is a vascular stasis, and this vascular stasis leads to fragmented columns of blood. So there is a fragmented columns of blood present over here. So it will look something like this. It will be like thick and discontinuous. Thick and discontinuous type of appearance is called as Kevorkian sign. This type. Okay. This is also known as cattle trucking. Okay, this Kevorkian sign sometimes is referred to as cattle trucking. Cattle trucking. Understood? Okay. So that were about the changes which are occurring in the eye. Then we come to something called as an algor mortis. Something called as an algor mortis, known as the post-mortem cooling of the body. We told that there is a loss of temperature of the body, and here in algor mortis there is a decrease in core body temperature. There is a decrease in core body temperature. Okay, means the rectal temperature. Core body temperature is rectal temperature. Superficial temperature, which we measure by sublingually or here in the neck or in the forehead, this is superficial body temperature. But there is a loss of core temperature of the body. Okay, core temperature, that is called as the algor mortis. Okay, and core body temperature is lost by the process of conduction. you know the three processes. It is the loss of temperature occurs: conduction, convection, radiation. So here, core body temperature or the rectal temperature is lost via conduction. And Algor mortis has specific inverted S shape or sigmoidal shape of graph. Okay, where we have different phases, and some factors are there also which will be affecting the Algor mortis. Okay, and we'll talk about Jaskow's phenomenon a bit later. First, let's talk about Algor mortis in toto. Then we'll go. Eye changes is done. Skin changes is done. I hope you are noting this all. See. Then, okay, what was the number? 3. Algor mortis. Algor mortis is the post-mortem cooling of the body. There is a loss in there is a loss in the core temperature of the body. This core temperature is measured in terms of rectal temperature. Rectal temperature. And this core temperature, this temperature is lost by the process of conduction to the environment. Understood? So this is all about your Algor mortis. So Algor mortis is the postmortem cooling of body, where three words, 2 3 words are important. It's the loss of core temperature, remember, and the process is called as the conduction. Core temperature is the rectal temperature. You have to know this. Okay, this much things are important, and we have a Algor mortis graph present over here. We have a graph of Algor mortis. A graph is present, which is a sigmoidal graph. This is a sigmoidal graph. Okay, so let's draw the graph. Know that Algor mortis is another term, rigor mortis is another term. Don't confuse. Don't ever confuse between Algor mortis and rigor mortis. People do that. That's why I'm telling. Uh, okay. Let's talk about here. Let's take temperature, and here let's take time. So we made a graph where temperature and time are taken, and we'll see a graph something like this. And we'll see something a graph like this. And this temperature is called as the ambient temperature. Ambient temperature, and this is the upper limit, and here we have three phases based on this temperature. So this is called as the phase 1, this is the phase 2, and this is the phase 3. So here in the Algor mortis graph, we have phase 1, phase 2, and phase 3, and here is the time taken 0 hours, and this graph continues. Okay, so phase 1 is the representation of the establishment of rectum losing its temperature through conduction to the surface. Okay, so phase 1 is basically the starting of the rectum establishment of the rectum losing temperature, ignore the background noises, by conduction to the surroundings. Okay, understood? Phase 1. Then phase 2, you can see a steep slope was there. Phase 2. So phase 2 is basically body loses its temperature very fast, very fast losing of temperature. This is phase 2, and then we talk about phase 3. We talk about phase 3. Phase 3 is the equilibrium between the external environmental temperature and the body's temperature. Okay, there is an equilibrium between the external temperature and the body's temperature, and after this phase 3, no more loss of temperature occurs. There will be no more loss of temperature which will be occurring. Okay, so that was about our algor mortis. That was about the things which you have to know in algor mortis. Let's talk about the factors affecting algor mortis a little. So what are the factors affecting algor mortis? Okay, so we have some factors which are affecting the algor mortis. So age, build, contour, this all, and then clothing. Okay, you can say environmental factors may that affect. Okay, so age is one of the factor. Okay, which will be extremes of age will cool faster. Okay, remember, extremes of age cool faster. Extremes of age cool faster. Then we'll talk about something called as the body. Okay, the build, A B. Okay, so you can remember like this: A B C. We'll see. Lean and thin bodies will cool faster. Lean and thin will cool faster. Okay, age is done, build is done. C is your clothing. Okay, so naked bodies will cool faster because whenever there is a clothing, there is an interference in the heat loss. Fast. Then, environment. What about the environment? So body will cool faster in colder environment. Body will cool faster in the colder environment, and often it also depends on the surface upon which body rests. It also depends on the surface upon which body rests. Okay, understood. Then let's after this, after algor mortis, this all you have to write in algor mortis. Just take a screenshot if you want to. This much is important in algor mortis. And if you have done this, let's move to the muscle changes now. So this was I know 3. Let's talk about 4. So what will be the changes in the muscle? So there is a primary relaxation of the muscle due to the loss of the muscle tone, and after that there is a rigor mortis which will be occurring in the muscle. Okay, the rigor mortis, and this rigor mortis, the cause of rigor mortis, as you have read in previous classes, the depletion of ATP due to which the muscle relaxation fails to occur. Okay, so first of all there will be stage of primary relaxation of muscle. We'll read about the Nystag's rule and the rule of 12 also in rigor mortis. Don't worry, we'll cover each and every aspect. Okay, primary relaxation of muscle due to the loss of muscle tone, and after that, will the second thing is the rigor mortis due to the depletion in the ATP inside muscles, by which relaxation fails to occur. You can write. Right, understood. So ATP levels, about if you want to know some statistics, ATP level mainly depletes by 15%. Okay, 15%. Whenever there's a decline in 50%, then rigidity in muscles start appearing, and when it depletes up to like 85%, the peak rigidity. Okay, the peak rigidity, and when it depletes in toto, okay, totally, then there's nothing to be there. So muscles all will relax, and there's loss of muscle proteins as well. Okay, then there's a secondary relaxation in muscles due to denaturation of the muscle proteins. So first primary relaxation, then algor mortis, then secondary relaxation of muscles, and this is due to the secondary relaxation of muscles is due to the you can say denaturation of the muscle proteins. This is due to the denaturation of the muscle proteins. Remember this. Then we have to talk about an important phenomenon which is called as the Jaskos phenomenon. Okay, Jaskos phenomenon. So Jaskos phenomenon is basically a patellar tapping reflex. Okay, a patellar tapping reflex, and here in the primary relaxation phase, it is positive. It's positive. It is seen in the primary relaxation phase. Okay, and is seen in the supravital period. Jaskos phenomenon is positive in supravital period. The supravital period is the time gap between the somatic depth and molecular depth and molecular depth. Okay, time gap between the somatic depth and molecular depth in this period, the Jaskos phenomenon is positive. Okay, understood? Then, what is Jaskos phenomenon basically? So, whenever the patella is tapped, let's say it's the patella, the tapping will lead to a twitching of muscle. So, basically, it is a patellar jerk. Okay, the quadriceps muscle basically, the quadriceps muscles upon which the patella rests. Okay, there's a twitching present. So, there is the in Jaskos phenomenon means that there is a twitching of the you can say quadriceps muscle whenever there is a tap on patella. And this indicates that the Jaskos phenomenon indicates that there is an intact contractile unit present in the primary relaxation phase. Okay, this indicates that there is a you can write here, indicates that there is a intact contractile unit, intact contractile unit in primary relaxation phase. Intact contractile unit in the primary relaxation phase. Understood? And this completes our Jaskos phenomenon. And in secondary relaxation phase, this secondary relaxation of muscles, this Jaskos phenomenon is negative. Jaskos phenomenon is negative. So that were all the muscle changes. If you want to take a screenshot, do take a screenshot quickly, and then we'll move ahead to the very important topic and very interesting topic of rigor mortis. Okay, rigor mortis or the rigidity of the death, and it is used to estimate the time since death. Okay, if you have taken the screenshot, let's move ahead. You must have heard about rigor mortis in previous classes also, but today we'll deal with it in more detailing. So after five, you can give five heading. Okay, give rigor mortis or the rigidity of death. Rigor mortis or the rigidity of death. So rigor mortis, that remember the development of rigor mortis is basically a gradual phenomenon. It appears in 12 hours, it stays for 12 hours, and it disappears for another 12 hours. Disappears in another 12 hours. So basically, 0 to 12 hours, rigor mortis starts developing. It's a stage of development. Then 12 to 24 hours, you can consider the stage of persistence. Okay, it persists for 12 to 24 hours, and from 24 to 36 hours there is a stage of disappearance. The rigor mortis will completely disappear, and more than 36 hours there is no rigor mortis at all. There is a denaturation of the muscle protein. There is a secondary relaxation phase of the muscle which is going on, right? So that is about the rigor mortis, and this is called the rule of 12 of the rigor mortis. We'll read about that. So first thing you write, development of rigor mortis, I am writing RM, is a gradual process. Development of rigor mortis is a gradual process, not a instantaneous process, and it is appreciated about your 12 hours after death. Most that after okay, you write that it occurs after the primary relaxation phase, as we saw here. It occurs after the primary relaxation phase of the muscle. Okay, so it occurs after the primary relaxation phase of the muscle, occurs after the primary relaxation phase of the muscle, and it follows two important rules. I'll suggest you all to make notes along with me. Nystag's rule and rule of 12. So this rigor mortis follows two important rules. Where, one is the Nystag's rule, and one is called as the rule of 12. Rule of 12, I told you earlier, we'll write it. Nystag's rule. Let's come to our first rule, that is our Nystag's rule. Nystag's rule. Okay, so Nystag's rule tells that rigor mortis will go away from the dead body in the same fashion as it appears in it. Okay, that is top to bottom. That is top to bottom. So earliest muscle to develop the rigor mortis is the eyelid. Remember, earliest muscle to develop the rigor mortis is the eyelid. Okay, basically it tells that there are exceptions. I will tell you that rigor mortis will start from the top of the body, that is the cranial portion of the body, to the caudal portion, and it disappears in the same aspect. It disappears from the cranial portion first, then to the caudal aspect. Okay, so rigor mortis develops and it disappears in the same fashion as it appears in the dead body. That is, if this is the person which is dead, so it will start from here, that is top to bottom, top to bottom. So it appears from top, the rigidity appears from top to bottom, and the rigidity disappears also from the top to bottom. Okay, this is the thing. And here there are some exceptions, that heart develops a rigor mortis at the earliest 1 hour after death. Okay, the exceptions are present, that heart develops rigor mortis at the earliest, nearly 1 hour after death. Okay, heart develops rigor mortis at the earliest, that is 1 hour after death. Okay, and the earliest muscle, external muscle to develop the rigor mortis is eyelid. Earliest external muscle to develop RM is eyelids. Understood? And by this Nystag's rule, you must be wondering that the toes, the muscle of the toes, the small muscle of the toes, would have been the last muscle of the body that is uh, showing a decline. That will. I was telling that there is another exception, that you must be thinking that the toes, muscle of the toes will be showing the disappearance of the rigor mortis at the last, but that's not the case. The last muscle of the body which is getting rid of the rigor mortis are the digital muscles of the hand, the small muscle in the finger, the digital muscles of the hand. Okay, so another exception I will write, the last muscles of body to get rid of rigor mortis are not that of toes, but are the digital muscles of the hand. This is another exception to the Nystag's rule. So Nystag's rule is important. Its exceptions are even more important. Okay, that's about Nystag's rule. And let's talk about now the rule of 12. So rule of 12, you know, from 0 to 12 hours, let's make a timeline like this: 0, 12, 24, 36. So here death occurred. Okay, at this point, time zero means the time of death. Okay, so for 0 to 12 hour, this is all hour, there is a rigor mortis sets in or appears. So this is called as the stage of appearance. Okay, the stage of appearance or the stage of development from 12 to 24 hours. Rigor mortis persists. So this is called the stage of persistence. And from this 24 to 36 hours, rigor mortis disappears. So this is known as the stage of disappearance. Stage of disappearance. Okay. And after 36 hours, there is no rigor mortis. There is no rigor mortis. There is no rigor mortis after 36 hours. Okay. That was about rigor mortis. And here in rigor mortis, another last thing of the day. Then afterwards, we'll wind up this lecture in 40 minutes. We'll keep short lectures. So this is just for the first lecture of the thanatology. This is a very short lecture. Okay. After that, there are some conditions which are stimulating rigor mortis. Conditions, simulating, not simulating, simulating rigor mortis. Okay, simulating means look like conditions of rigor mortis which appears like rigor mortis but it is not. Okay, rigor mortis जैसे दिखता है पर rigor mortis है नहीं है असली में. ठीक है, जैसे cadaveric spasm is there, heat stiffening is there, cold stiffening is there, and gas stiffening is there. All the stiffenings and cadaveric spasm, these are four conditions which look like rigor mortis but are not rigor mortis at all, right? So here we'll write there are some four conditions which look like rigor mortis but are not rigor mortis. So conditions simulating rigor mortis. First one is called as a cadaveric spasm. Second one is called as a cold stiffening, heat stiffening, and four is the gas stiffening. Okay, cadaveric spasm, heat stiffening, cold stiffening, and gas stiffening. So cadaveric spasm is due to the complete loss of ATP from a group of muscles before death. It is a antemortem phenomenon. Antemortem means before death. Okay, so it is a cadaveric spasm is basically referred to as a complete loss, depletion of ATP from a group of muscles before death. So the body will remain in a contracted state post death. So body remains in a contracted state post death. So the body remains in a contracted state post death, and the physician, the examining person, the post-mortem specialist can confuse this cadaveric spasm with the rigor mortis. It appears like rigor mortis, but it is not actually rigor mortis. Okay, and cold stiffening means if the temperature is very less. Okay, if the body is kept in a you can say cooling temperature in the mortuary, the fluid of the body will solidify. The intracellular fluid present in the body solidifies. Cold stiffening is due to the solidification of body fluid when it is kept in cold conditions. And this will also appear like the rigor mortis. This will also appear like rigor mortis. Then what is heat stiffening? Heat stiffening means that whenever the body is exposed to temperature more than 65 degrees Celsius, we say 65 degrees Celsius, then the muscle proteins basically coagulate. Okay, so there is a coagulation of muscle proteins when body is kept at you can say 65 or more temperature, and this is called the heat stiffening. What is gas stiffening? Whenever there is a death, okay, the bacteria will decompose of the dead body, okay, and it will lead to the formation of gas inside the body. So this is the bacterial decomposition of the dead body, and it will also simulate the rigor mortis. It will also appear just like rigor mortis. So it is basically bacterial decomposition of dead body, and it is also look alike of rigor mortis. Also looks like rigor mortis. So that's all for today. We discussed a lot of things today, and this is the lecture one. Obviously, we'll continue this topic. We'll continue this topic in the next lecture, and the next lecture we'll talk about post-mortem staining. Okay, we'll talk about postmortem staining and the postmortem lividity. That is the paleness of the areas, okay, of the dependent areas of the body. Okay, this is called as the contact flattening or the livor mortis. Okay, the term is the postmortem staining is called as livor mortis. Okay, livor mortis. And then we'll move to other changes. After we'll talk about the different etiologies of postmortem staining, and we'll see a graphical representation of the postmortem changes, as well as we'll see another important change, that's the greenish discoloration of the right iliac fossa. Due to the loss of due to this formation of methemoglobin, okay, H2S gas basically. Then we'll self hemoglobin, sorry, I told methemoglobin. Then we'll saw some features like marbling of the body. Okay, the body, you must have seen in the dead body there are some veiny structures, greenish black or greenish blue vascular structures that are visible in the dead body, in the arms, in the shoulders and all. Okay, this is called as a marbling. Okay, seen after about you can say 36 to 72 hours of the death. Okay, and this is due to the sulfamethemoglobin, which is formed due to bacterial decomposition. Okay, greenish discoloration. Understood? So that was about today's lecture, and I hope you enjoyed the lecture. I hope you all felt like Dr. Salunke, and you will read the book as it is. You don't need to read the book. If you have made notes with me, just revise the notes. We talked about many things today: immediate changes, early changes, the changes we talked about, eye changes or the Kevorkian sign, and the Tachynoid certificate. Algor mortis. Algor mortis is important. Jaspers phenomenon you must know, and rigor mortis is very important. So we talked about a few basic concepts in thanatology in the postmortem changes. That's all in today's lecture. If you enjoyed the lecture, do like, share, and subscribe. And let's meet again in any other topic with any other thing to read and with even more higher juice. Okay. So till then, bye bye. Take care and